Hello everyone. Good morning guys. How are you? Guys, am I audible and visible to you? Please confirm me once. Okay. In total 2 or 12. Hi Senapati, am I audible and visible to you? Senapati? Shillong, is there 12 students in total or 12 students in one room? Is this section A's attendance or in total there are 12 students at the Shillong Center? Okay, that's cool. Senapati? Guys, can you hear me? Okay, that's good. So guys, how was your holiday? Have you enjoyed that? Oh, that's good. Okay. So guys, can you please tell me what was the topic that you were discussing? And please tell me, is anybody has any doubt till now? They can ask me first, so I'll start with your doubts, and after that we will continue with our next topic. Please share the topic that I was discussing with you. The topic. Okay, hydrogen spectrum has done. Anyone has any problem till the hydrogen spectrum? Anybody wants to ask me anything regarding that? Numericals or anything else? Most probably today we'll wind up the structure of atom, and I'll share the sheet of structure of atom with you. And guys, please tell me the day when you want to discuss your doubts based on the redox reactions. How many of you has completed that sheet of redox reactions? Anyone? Now you all are looking at the faces of each other. Guys, have you attempted that sheet? That sheet was for you. You're supposed to do that. Please tell me a day in the current week or starting of the next week. And till then, make sure that everybody has attempted all those questions so that I can take your doubts. Okay? Okay, that is not a problem, dear. Please tell me a day. Then on that day you want to discuss your doubts. And make sure that everybody should able to solve all those questions. I mean to say that has attempted at least all those questions. I'll take up your doubts. Okay, Monday, I don't think so that Monday we have a class. Okay, in the next week, any day, any first day when we have a class, either Monday, Tuesday or Wednesday. Okay, most probably the class will be on Wednesday. Okay, so on that day, first of all, I'll take your doubts of redox reactions. Okay, so everybody has still some time to attempt those questions, and I'll discuss structure of atom, sheet of structure of atom by today. Okay. So, can we start, guys? Is everyone ready? Can we start? Okay. So you have doubt in redox reactions. You want doubt class for redox reaction before the Saturday test? I think we have class on Friday as well. Please tell me. We can do that one as well. You can decide. Okay, that's cool. Is everyone ready for the Friday doubt class for redox reactions? Today is Wednesday. Okay, so yeah, will be fine. That will be fine. Everyone can do those questions. I think there are 100 questions, and you can do those. You can attempt those questions easily in 2 days. Okay, so guys, this is final. Friday we will have a doubt class of redox reactions. Okay, so guys, come with your doubts on Friday. Okay. So guys, let's begin with today's session. We were discussing about the hydrogen spectrum. Okay. I think so. I have discussed the Lyman series, Balmer series, Paschen series, Brackett series, Pfund series. All those spectral series have been discussed with you. Okay. Even I have discussed the Rydberg formula as well with you. See, Rydberg formula. That was R 1 upon N1 square minus 1 upon N2 square into Z square. I think this one has been discussed with you. Okay. This is the Rydberg formula. The value of R was 1.1 into 10 to the power 7 meter inverse. Okay. You can convert this into centimeters as well. Okay. I was discussing about the lines. See, I have discussed this one with you. See, I'm assuming that whenever transition takes place, it will land on the n equal to 1. Means the final destination for the electron will be n equal to 1. See, this is 2, 3, 4 and 5. If electron jumps from 2 to 1, if electron jumps from 2 to 1 second. Two to 1, this is known as your first line. I think I have discussed about it. First line. For the first line, N1 will be 1 and N2 should be 2. If electron jumps from 3 to 1, this is your second line, where N1 is 1 but N2 is 3. Okay. If I say electron jumps from 5 to 1, this is your fourth line, where N1 is 1 and N2 is 5. Okay. So guys, I have a question for you. Please tell me, if I say the last line, in that case, N1 is 1, what should be value of N2? My question is, if I say the last line, in case of last line, what should be the value of N2? Can you please tell me what should be the value of N2 for the last line? Very good. That will be infinity. Okay. If I say last line, then N2 should be infinite. Guys, remember this was the case for the Lyman series. Okay. If I say that Balmer series, okay, we know that in case of Balmer series, one, 2, 3, 4, 5 and then 6. We know that the final destination is fixed, which is at n equal to 2. So, If I say the first line, then to obtain the first line, remember in case of Balmer series, N1 should be 2, but N2 should be 3. If I say the second line, this is your second line, N1 should be 2, but N2 should be 4. Can please anybody tell me what would be the 10th line? Means for 10th line, what should be the value of N2 in case of Balmer series? For the 10th line, the value of N2. $11. Anyone else? $22. No. See, there's some problem. Look at this. When you obtain the second line, the N2 becomes 4. If you obtain the third line, see this is your third line. Tell me the value of N2 for the third line. It should be 5. Guys, look at the spectrum carefully, that the value of N2 is increasing by 2. After the first line, see, if I talk about third line, if I'm saying the third line, it means 3 plus 2 is what? 5. If I saying the second line, which means N2 is 4, which is 2 plus 2, 4. See, in case of Balmer series. Let's try to observe this pattern in case of Balmer series. Because in the next series, I'll just write the values. See, for the first line, N1 was 2, but N2 was 3. Actually, I have to do this one, plus 2. For the second line, excuse me, for the second line, no changes in the N1, N2, 2 plus 2, 4. For the third line, this is 3 plus 2, 5. 10th line, N2, 10 plus 2, 12. Are you getting this, guys? Are you getting this? Hi, good morning, Itanagar. Hey everyone, guys, is it clear to you that what I was trying to do? Anybody has any problem? Can please anyone tell me what should be the that school? Can anybody please tell me what should be the value of N2 in case of 19th line? Value of N2 in case of 19th line? 19th line. Good. Last line, value of N2. Last line, value of N2. Very good. That will be infinity. Okay. So guys, you have to just remember this one. Okay. See, if I talk about Lehman, Balmer, then Paschen. We know that N1 will be 3 and N2 will be 4. This is data for the first line. Is it clear? N1 is always fixed. N2, let's talk about the N2 for the second line. Can you please tell me what should be value of N2? What should be a value of N2? Very good. How did you obtain that n equal to 5? Simply add 3 to the 2. N2. If I say the third line, yeah, very good. That's what guys you have to observe. What should be N2 when we talk about the third line? Very good. Tell me 25th line. Value of N2 for 25th line. Twenty-fifth line, value of N2. Very good, which is 28. I hope so that guys now you can do for the P-fund and bracket series as well. Okay. Guys, you can please copy this. Please copy this. This was for the Lyman. Once you have copied that, please inform me. Please tell me, is there anyone who has got any confusion or doubt regarding this one? Is it clear to everybody? Is it clear to everyone? Good. Please copy. Next question will be for you. Okay. So guys, let's move on. I hope so everybody has copied that. Oh, please copy this one as well. Question series. Please copy this one as well. Cool. Guys, this question is for you. Calculate wavelength of third line of bracket series in hydrogen spectrum. I hope so everybody knows that you have to use this formula. 1 upon n1 square minus 1 upon n2 square. Guys, you need not to solve this. Okay, you can solve this in terms of RH. Please do not put the value of RH. Okay, that typical value 1.1 10 to the power 7. Don't put that. Solve this in terms of R. Okay, by just putting the value of n. Please solve this and tell me your answer. Itanaga, are you there? Senapati? Okay. Is there anyone who has got the answer? Only 45. I think so there should be something in the fraction. Guys, please tell me what was the value of n1 and n2? For the bracket series, n1 should be 4 and n2 should be 7. Is it true? Have you used that? Yeah. Yeah, that's cool. So you should get the answer. See? 1 by lambda is equals to RH, 1 upon 4 square minus 1 upon 7 square. So this is your R, 1 by 16 minus 1 by 49. Okay? Take the LCM. R, 49, 16 is your 49 minus 16, 1 by lambda. You have to just solve this. After solving this, you will get your answer. So lambda should be 49 into 16 upon 33 times of R, minute. Sorry, meter. Please copy. Any point of confusion or doubt? Please copy this. Have you copied that, guys? Okay. Guys, I have a question for you. That in Lyman series, what should be value of N2 to obtain spectral line of maximum wavelength? Options are, it should be 3, infinite d 5. What should be value of n2 to obtain spectral line of maximum wavelength? Okay. How many of you says that is C should be the right answer? C should be the right answer. Okay. Guys, our net speed is not so smooth, so that I cannot see how many of you has raised your hand. Okay, how many of you says B? Or C, the student who has opted the C first has changed their answer to the B. Is it like that? Itanaka, what did you say? Okay, very good. So guys, please look at this very carefully. Look at this very carefully. We know that E is inversely proportional to the wavelength. Do you agree with this point? That E is inversely proportional to the wavelength? Is there anyone who is not agreed with this? Okay, that's good. We know that the formula for E is what? Minus R Z square upon N square. We know that. So E is proportional to what? Minus of 1 by N square. I hope so you agree with this point as well. Anybody has any confusion regarding this one? Do you agree that E should be inversely proportional to the N square? Please confirm me once. Okay. Guys, do we have studied that if N increases, E also increases? Do we have studied that if N increases, E is also increases? Do you remember that? That with increase in N, E increases because of that negative sign. Wow, really? Okay. Okay, fine. See? Okay, guys, so then look at this very carefully. See the explanation. I am saying X is inversely proportional to Y. I'm just clearing the concept. Please do not copy this. In the second case, X is inversely proportional to the 1 upon Y. Okay? This is the case 1, this is your case 2. I am saying Y increases. What should be impact on X in the first case? I am saying Y is increasing. What should be impact on X? Very good. It should decrease. Okay. Now, here Y increases. What should impact on X? Here. Is everybody agreed with this point? If Y increases, X should also increase? If anybody has any point of confusion or doubt, you can please tell me. I can take another example. Yeah, that's absolutely true, that X should also be increased because of that negative sign. Are you sure that you are clear with this point? Everyone? Shillong, Itanagar. Okay. Okay. Wait. I'm using the relation x is inversely proportional to 1 upon y. I'm saying the value of y is 1 in first case. Here, the value of y is 2. Okay. Now, here the value of y is 3. See. What will I get? I have to put these values. Guys, remember, I'm putting these values. Okay. So here, I'm removing the proportionality sign, okay, just for the calculation, and we are assuming that k is a constant over there. So this is what? Minus 1 upon 1, which is minus 1. If I talk about this one, x will be equal to minus 1 by 2, okay. If I talk about this one, x should be equal to what? Minus 1 by 3, okay. Guys, please compare these three values. Please compare these three values and tell me where you have got the maximum value and where you have got the minimum value of x. Compare these values, minus 1, minus 2 and minus 1, oh sorry, minus 1, minus 1 by 2, minus 1 by 3. Tell me the biggest value. On solving, you will get this minus 0.5 and you will get here minus 0.33. What will be the biggest value among these three? Very good. That 0.33 is greater than minus 0.5 is greater than, what was the first value? Is it true? Do I have written all the values correct? Is it the right order? Is it the right order? Guys, please do not copy this. This is just for the sake of the explanations, for concept clarification. Is it right? Okay. So guys, please tell me, we have got 0.33 when y was 3. We have got this one when y was 2. And we have got this one when y was what? 1. See, these are the value of x and these are what? Value of y. See, y is increasing in this manner and x is also increasing in this manner. Okay. So guys, by putting the negative value, if it is inversely proportional, then on increasing the value of the denominator, in that case, the variable part will also increases. And guys, you can simply think about it that if I say this case, you say, sir, on increasing y, x should decrease. Okay. I am saying just reverse this. Just reverse this. Okay. So obviously guys, you are putting the negative sign over there. So obviously the whole result will get reversed. See, if y increases, in that case, x should also increase because we have got this negative sign. Okay. Now is it clear to everyone? This is the whole summary for this one. Is it clear to everyone? Anybody has any confusion right now? Now is it clear to you? Okay. That's good. So guys, actually I was using this one. Okay. So, to obtain the maximum wavelength, the N2 should be 2. N2 should be 2. The gap between the two transitions should be minimum to get the maximum wavelength, because in that case energy will be minimum. Okay. If in the question they says that we have to obtain the minimum wavelength, then N2 should be maximum. In that case it will become the infinity. Okay. Please copy this question. And you can copy this one as well. Need not to copy that explanation. Please copy this question. Now, can you remember that To obtain the maximum wavelength, N2 should be minimum, and to obtain the minimum wavelength, N2 should be maximum. Copy please. Is there anybody who has got any doubt? Okay. Copy this one as well. Okay. Copy this one. Or you can copy that section. Please copy. And now please answer to this question. In Balmer series, what should be value of N2 to obtain spectral line of maximum frequency? Options are 2, 3, 4, infinite. Guys, remember that relation. E is inversely proportional to, E is inversely proportional to the wavelength, but directly proportional to the frequency. Okay. Please tell me the answer. You can correlate this one with the wavelength as well. We know that wavelength and frequency are inversely related to each other. I have got the mixed answers. How many of you says B? Please raise your hand. How many of you says B? Okay. Very good. Guys, you can say maximum frequency or minimum wavelength. We know that, na? That C is equal to nu lambda, and we can say that nu is inversely proportional to lambda. See? Maximum frequency or minimum wavelength both has the same sense. So obviously, I have given you the explanation regarding the wavelength. Okay? So obviously, you can correlate with that one. When we can obtain the minimum wavelength? When we have the N2 is equals to infinite. Okay? I hope so it is clear to everyone. Guys, is it clear to everyone? अरे कोई ऐसा तो नहीं जिसको समझ में नहीं आया हो? कोई झूठ तो नहीं बोल रहा है बैठ के यहाँ पे? जो झूठ बोल रहा है उसको पाप लगने वाला, उसको बता रहा हूं मैं. Guys, is it clear to you? Remember, these kind of questions are asked in your examinations. Okay? चलो आगे शुरू करें. Please do this question. Calculate ratio of maximum wavelength of Lyman and Balmer series. करें. Please do this question. and tell me the answer. Who has got this answer? Please write your name as well. Guys, remember, these are the spectral series. So we have always get N1 as well as N2. 2, 4, 9. Guys, look at this. Anyone else who wants some more time? Or can I start? Is there anyone who is still trying? Okay, cool. Please take your time. Okay, who has got this answer? Okay. I'm giving you 2 more minutes, guys. Who has got this answer? Okay, very good. Who has got this answer? Very good. Please cross-check it once. Please cross-check it once. Because wavelength is inversely proportional. Itanagar, you have got absolutely right answer. Yeah, okay, guys, so let's begin. Okay, in the last I have got 2 very near answer. Okay, guys, look at this. 1 by lambda is equals to R 1 by N1 square minus 1 by N2 square. Okay. So guys, we have to calculate the ratio of the wavelength for the Lyman to the Balmer series. Okay. So guys, first of all, what we have to do, lambda should be equals to 1 upon R N1 square into N2 square upon N2 square minus N1 square. Guys, can I write this formula? Can I write this formula? Z will be constant, so I am not writing that. Please first of all clear it to me that can I write this like this as well? Okay, that's it. So guys, we will get our answer very easily. Lyman series upon Balmer series. 1 upon R. To get the maximum wavelength, N1 should be, in case of Lyman, 1 and N2 should be 2. So this one your 1 square into 2 square upon 2 square minus 1 square. 1 upon R 2 square into 3 square upon 3 square minus 2 square. Okay. This one will get totally cancelled out. Okay. we can solve this one. This is your 4 upon 4 minus 1, which is 3, upon 2 2s are 4 and 9, 36, upon 3 3s are 9 minus 4, which is 5. So on solving this is 5 by 36. So it should be 5 by 27. Guys, are you clear with this question? See, in the examination, you will get your answer as a 25 by 27 by 5, and the correct option would be 5 by 27. That will be the only difference in the examination. Okay? So guys, please be careful. Okay? If you have got any confusion, you can please copy this formula as well. 1 upon z square as well. Little bit simplified form to obtain the ratios. Okay? These are very much helpful in your examinations. Please copy this. By the way, how many of you has got the answer 5 by 27 at the Shillong Center? How many of you has got the answer 5 by 27? Guys, have you copied that? Okay. Copy this one as well. Shillong Center, the student at the first bench. Dear, have you copied that? The student at the first center. Oh, sorry. First bench. Have you copied that? Okay, that's good. So guys, next one. Question is, sorry, this is not a question, this is a concept. Calculation for number of spectral lines. Total lines are equals to n2 minus n1, n2 minus n1 plus 1 by 2. You have to remember this formula only. Okay. Again, we have information regarding the n1 and n2. They will be different in case of different spectral lines. In case of Lyman, it would be different. In case of Balmer, it would be different. Bracket, Paschen, it will be totally different. Okay. So, let me take an example. See, how many total spectral lines would be obtained if electron jumps from fifth orbit to ground state. Okay, first of all guys, please copy this question. See, according to question, N2 should be 5 and N1 should be 1. Just put these values and we will get our answer. Total lines would be 5 minus 1, 5 minus 1 plus 1 upon 2. On solving, 4 into 5 by 2, answer would be 10. Any confusion? Guys, please copy this. Is it clear to everyone? You have to just remember that formula. Just remember that formula. Copied? Okay. Next question for you. How many spectral lines will be obtained in bracket series if electron jumps from 7th orbit? Tell me the answer. Okay. Anyone else? Guys, have you done that question? Itanago, have you attempted? Senapati? Guys, remember this is a bracket series. So in case of bracket series, please tell me the value of N1. N2 is given to you is 7. What should be the value of N1 in case of bracket series? Okay, it should be 4. So 7 minus 4, 7 minus 4 plus 1 upon 2. Just solve this. 3 into 4 by 2. Answer should be 6. Please copy this. So guys, that's all about your hydrogen Bose atomic model. Okay, all the questions and concepts related to Bose atomic models have been covered. Okay, so we have to just write the limitations of the Bose atomic model, and after that we will proceed with the new concept. Limitations. First, please copy it along with me. It was applicable to hydrogen-like species only, that is single electron system. Means those species who has more than one electron are not explained by the help of Bohr's atomic model. Okay. Number 2, it does not explain why angular momentum is equal to NH upon 2 pi. Okay, guys, that was just a postulate, that was just an assumption that MVR is equal to NH upon 2 pi, but there was no explanation for this one. Copy these 2 points first. There was no explanation for this one. Copied. Next, it does not explain fine structure of spectral lines. Number 4, it does not explain splitting of spectral lines in electric field. This is known as a Stark effect. Guys, you have to remember this one. This is known as a Stark effect. And in magnetic field. This is known as your Zeeman effect. Copy this one please first. And please confirm me once after copying that. Copied. Okay, so next point. It does not consider de Broglie concept and Heisenberg's uncertainty principle. So these are the limitations of the Bose atomic model. Okay, and guys, this is the new topic for us, which is the de Broglie concept and the Heisenberg uncertainty principle. Ultimately, this model could not explain these two concepts. Okay, that's why this is one of the drawbacks by which this model is got discarded. So these are the last two topics of this one, and after that we will move on to the quantum mechanical model of the structure of atom, which is the last topic after these two topics. Okay, please copy this once. You guys need a break, or we can continue. Okay, that's cool. So guys, let's take a break of 5 minutes and see you in the 5 minutes. Okay. Hello everyone. So how was your break? Is everybody has joined? Shillong, Itanagar, Senapati. Okay. So guys, is your break was refreshing? Or that was just like a break? Okay. Cool. So guys, anybody wants to ask me anything till now? Any query, any question, anything that you want to ask me before proceeding? No one? Those who are busy with their phones, can you please, the question, which question? I'm saying those who are busy with their phones, can you please tell me which game you are playing right now? Are you playing any game right now? Those who are busy with their phones? Senapati, are you there? Okay, cool. So guys, finally, let's start again. Okay, this time. Guys, before that, you have to just write the answer. Okay, please do not copy this question. Please do not copy this question. Listen to me very carefully. Listen to me very carefully. I'm giving you options first, and then I'll ask you the question. Okay. 1857, 1905, 795, and D. These are the options. Okay. And the question is, in which year Einstein gave second law of motion? In which year Einstein gave second law of motion? I hope so everybody has heard that question. Mark your answer. Okay, how many of you says A should be the right answer? Okay, anyone else? See, there are 4 options. Make 4 groups and opt all the options. Definitely one of them will be right. Anyone there who wants to change their answer? Itanagar, you want to say anything? What would be your answer? Okay. Okay. Guys, by the way, I don't think so that you have heard my question very carefully. I said Einstein. First of all, please tell me, who gave the laws of motion? Newton or Einstein? Who gave the laws of motion? Einstein or Newton? I'm still getting options. This was a trick question, guys. Please listen to me very carefully and try to use your brain. Okay. So guys, laws of motion was given by the Newton, not by the Einstein. Okay. So, any doubt? Okay. So be ready with few more questions in the break time. Okay. Try to read the question very carefully. Don't just look at the options. Okay. So guys, let's begin. The next is de Broglie. See, de Broglie was a great scientist, one of the great scientists. He simply said that as photons, which is a light, has a dual behavior. Dual behavior means particle nature as well as wave nature. Okay, as of light contains a dual behavior, that's why matter should also have a dual behavior. If we are saying that a particle is moving, then it should have the dual behavior, which is the particle nature as well as wave nature. That was said by the de Broglie. Okay, even he has proved his concept by the experiments as well. Okay, so he simply said that as light has, guys, you can copy this statement along with me. Light has dual behavior. That is particle nature as well as wave nature. Therefore, matter should also have dual behavior. Okay, and guys, now I'm driving the equation for this one. Okay, please copy this statement. After that, please do not copy anything till the time I have finished that derivation. Okay, you will stop after copying that. Okay, so guys, let's begin. Everybody should focus on the screen. Look at the screen. See, we know that E is equals to mc square. Okay, this is the equation given by the Einstein. Okay, energy is equals to what? Mc square. And this is the particle nature actually. This is what? Particle nature. In case of waves, E is equals to what? hc by lambda. This is your wave nature. I'm sure that you have aware with all these formulas. You have information regarding these formulas. Okay. So guys, as we know that E is equals to mc square and E is equals to hc by lambda. So according to mathematics, I can put equal both of these. So we will have mc square is equals to hc by lambda. One of the c will get cancelled out. This one will cancel this one. On solving, we will get lambda is equals to h upon mv. Sorry, h upon mc. Okay. So guys, this is the wavelength when we talk about the photons or when we talk about the light. Okay. Because c is what? Speed of light. If we talk about the matter or any moving charge particle, or we can say any matter in this world, definitely that will have a certain mass or certain velocity as well. Okay. So this formula can also be written like this. H upon mv. See. One second. See. Here, c is the speed of light. If light is not given to us, definitely we will have some other object and in that case we will be what? Velocity of that object. Velocity of object. Velocity of object. Okay, and m will be what? Mass of the object. M will be mass of the object. First of all, please copy this. Please copy this one, and after that copy that. Copy this. Okay. M is mass of object. Okay. And guys, we know that momentum represented by the P is equals to what? Mass into velocity. Okay. So I can say that lambda should also be equal to what? H upon P. Whereas H is a constant. So I can simply say, see, this is one of or your formula. As well as we can say lambda should be inversely proportional to what? Momentum. Okay. So guys, you can copy this one as well. Please copy this. Done? Any confusion or any doubt? Is it clear to everyone? How do we get the lambda is equals to H upon mv? Okay. Now guys, look at this. We know that there are some results that you have to simply remember. We know that kinetic energy is equals to what? Half mv square. Okay. I'm doing that, I'm multiplying m on both the sides. Okay. After multiplying this, I'll get m into kinetic energy would be equals to 2 m square v square. I have just cross multiplied 2. Okay. So I can say that mv square is equals to twice into mass into kinetic energy. Okay. So I can say that mv should be equals to under the root 2 into m into kinetic energy. Okay. We have got the value of mv. Now you can put this value of mv in the first equation, which is lambda is equals to h upon mv. So this one will become 2 into m into kinetic energy. Copy this formula as well. You have to remember this formula. Okay. If you don't remember the derivation, okay, or you have to simply remember this formula. If you are clear with the derivation, that is quite easy to remember. Okay. Copy this one as well. Copied? Okay. Next, when a charge particle carrying charge Q is accelerated by applying potential difference of V. Then, guys, remember, whenever we put a charged particle into electric field, or we can say at some potential difference, in that case, the formula of the energy, see, first of all, the formula of the energy is charge into potential. That you will learn about it in physics as well, in the chapters electrostatics. Okay, whenever you put a charged particle in a potential difference, it will always accelerate. Okay, it will always move. So obviously, in that case, the formula of the energy is the charge into potential. But the point is, guys, the energy will be the kinetic energy, because electron is in moving state. Electron is moving over there. So we can say that this energy is actually what? Kinetic energy. I have used the value of charge as a Q and potential as V. So guys, this is again a new formula. Okay. If you have studied electrostatics, I'm sure you have learned about it. But if not, then you can remember this formula, that whenever you put a charged particle in an electric field, or we can say that at some potential difference, in that case, kinetic energy would be equal to Q into V. Okay. Please copy this first. Guys, you have to remember this formula. Copied? Okay, now we know that lambda is equals to h upon under the root 2 into m into kinetic energy. Okay, so guys, we have just learned that kinetic energy is equals to Q into V. So I can use that value over here, and after using that, this one will be 2 into Q into V. Okay, and the important point, guys, here the question will be asked for the electron. Okay, in the 99% cases, or I can say in the NEET examinations, question will be asked for the electrons only. So you need not to remember this big formula. Okay, you can remember simply this one for electron, that lambda would be equals to under the root 150 upon V angstrom. V is the potential difference. The above formula is the general formula, but the formula which is given to you at the bottom is the for the electron only. And guys, this is the whole under the root. Remember, this is the whole under the root. Okay. Please copy this. Any point of confusion or doubt? Can you remember these formulas, guys? These are very much important for you. Okay. Question for you. What should be wavelength associated with an electron placed in an electric field at a potential difference of 30 volt. .30 volt. Please solve this question. Please do not draw that flag as well. Please do not draw that flag. That was by mistake written over there. Guys, what is the answer? Is there anyone who had solved that question? You can leave the answer in the root if you are not able to solving that root value. Shillong, Senapati, Itanagar. Yeah, that's the right answer. Lambda is h upon 150 upon 30 angstrom. So this is your root 5 angstrom. And the value of root 5 is 2.40. 2.2. 2.2 angstrom. Okay. Guys, do the next question. What is the ratio of de Broglie wavelength for electron accelerated through .200 volt and 50 volt. Copy this question first, and after that I am giving you the options. Copy this question, and after that I'll give you the options. You can start solving, and after that you can match with the correct option. Options are let me check. 1:2, 2:1, 3:10, 10:3. These are the options, guys. Okay. Who has got this answer? Okay, good. What about you guys? What are other students doing? Guys, are you solving this? Okay, that's cool. So, let me solve it. De Broglie wavelength. We know that de Broglie wavelength is equals to 150 by V. This much angstrom. Okay. So guys, if you don't mind, can I write it like this? Or you can do in that manner as well. Okay. Okay, we have got some different answer as well. Okay. So, lambda 1 upon lambda 2 would be equals to under the root V2 upon V1. Okay. So, under the root V2 is given to us is 50 and this is your 200. It should be what? Under the root 1 by 4. So, on solving it will be 1 by 2. Any confusion? I think so you have got, okay, very good. So option A would be the definitely right answer. Okay. So guys, you will get these kind of questions, okay. It might be asked in terms of kinetic energy as well, okay. So to solve the questions quickly and easily, first of all you have to remember the formulas, okay. So that's all about your de Broglie concept, over. Next one is Heisenberg uncertainty principle. He simply said that it is impossible to determine simultaneously exact position and momentum of a moving electron. Okay. He simply said that if we are calculating velocity, in that case, means if we want velocity more accurately, in that case we cannot calculate its position more accurately. Okay. If we are looking for a position, in that case we won't have the accurate value of the velocity. Okay. Out of these two terms of velocity and the position, either we are able to solve it, or we can say that either we will get the more accurate value for the velocity or more accurate value for the position. Okay. So this was the Heisenberg uncertainty principle. So guys, you can write down the statement along with me, that it states that it is impossible to determine simultaneously exact position and momentum which, or we can say velocity of a moving electron. In an atom. Okay, this was the statement said by the Heisenberg. After that, to prove his point, he given his formula as well, okay, a mathematical derivation, we can say a mathematical relation to prove his point. So we have to remember that mathematical relation as well. Please copy this statement, and after that let's see what was the mathematical relation. Okay, so let's move on, guys. Delta M, sorry, not delta M, M into delta V into delta X should be greater than h upon 4 pi. Okay, this is the formula, or I can write this formula in this manner as well. See, M into V is what? Momentum. So I can see the change in momentum into change in position should be greater than h upon 4 pi. For solving the question, we need not to put the value of greater than, we will simply put it as a equal to. Okay, so these are the formulas. Delta V is your uncertainty in velocity. Delta X, uncertainty in position. Copy this formula. Copied. Okay. Guys, you can remember this one. Need not to solve h upon 4 pi always. You can remember this value is your 0.527 into 10 to the power minus 34 joule second. Okay, or you can simplify this one as well, or you can simply remember 0.53 into 10 to the power minus 34. Need not to solve the value of h upon 4 pi always. Simply remember this value. That will help you out to solve the question very quickly. Okay. After that, I am giving you a question. Calculate uncertainty in position of a cricket ball having mass 150 gram and having uncertainty in velocity of 1 angstrom. Guys, copy this question first and use your formula. You have to simply use this one. X m dot v is equals to h upon 4 pi. That's it. Need not to put the value of equal to. Use this formula and tell me the answer. Solve this and tell me the answer. Done. Guys, have you got the answer? Oh, the power is in positive or negative? Kindly confirm. Oh, I have got two different answers now. Okay, that's good. Yeah, that would be the answer. Guys, look at this. We have to calculate the delta x. The value of h upon 4 pi is already, you have to remember, minus 34 upon mass is 150. This is in grams, guys. First of all, make sure that mass should be in kgs. Okay. So this is 10 to the power minus 3. And this is 1 angstrom, which is 10 to the power minus 10. Okay. So when you will solve it, you will get 3.5 into 10 to the power minus 24. Okay. Meters. Any confusion or doubt? Anyone? Anyone wants to ask me anything? सभी को समझ में आया? Can I move on? Okay. Senapati and Itanagar, guys, any confusion or doubt? You wanna ask me anything? Is it clear to is it clear to you? Next question for you guys. Do it carefully. Okay. If delta x is equal to 0, then delta p would be for a for an electron. Options are 0, 1, infinite, D. None of these. Okay. कितने लोगों से आया? Please write your name. Who has got C? I know it is additional work to write your name after getting the even a correct option. Might be a correct option. Okay. Very good. Anyone there who has got other answer? I mean to say that A. Guys, remember one thing, that this is just for example. Y is any number upon 0. If you divide it with the 0, result is infinite. Okay. So option C should be the right answer. This is your delta. What we have to calculate? Delta P. Sorry. By the way, this is just an example. Okay. You can put these values and you will get your answer. Okay, very good. You guys are superstar. You all will become doctor. Any confusion or doubt? You want to ask me anything? No question? Okay, better. So finally guys, that's all for today's session. I mean right now session. After that, I'll see you at 1:30. Okay. Again you will have a chemistry class at 1:30. So please have your lunch, and after having your lunch, I'll see you in the half an hour. Okay, and we'll continue with the quantum numbers. Okay. So guys, take care. Bye bye.